Hi, Lindsay Drachenberg here. Today we are doing our second presentation for Chem 125, which is our interactive advanced concept presentation. So today is a fun one, in my opinion. We get to do a lava lamp. So I have done this experiment before in a non-science setting, just for fun. So I'm excited to get to do it again now that I know the reasoning behind the reactions and such like that. So with the lava lamp, as you can see on the board, it was created long ago by Edward Craven Walker. And he did it a bit differently using wax and clear liquid. So we are going to modify those, and we are going to be using water, vegetable oil, food coloring, and an Alka-Seltzer tablet. So same experiment, just a little different. So as I said, we have our elements here, and we're going to do the experiment in just a minute after we talk about kind of the groundwork for it. So with that, we are going to talk about limiting reactions and excessive reactions. So limiting reactions are the reaction that completely consumes or determines the amount of product created. So it limits the product based on what it has. Where excessive is a reactant present in a greater amount than necessary to react with all the limiting reactors. So excessive doesn't really dictate much, limiting dictates a lot. So as our book used as an example with the bread and ham, for sandwiches, they had 6 pieces of bread and 2 pieces of ham. So if we're making a double bread sandwich, our ham would be the limiting factor, since we would use 4 of our bread and both of our ham, we would still have 2 excess reactant, excess pieces of bread. So that's kind of the idea with that. So among doing the experiment, we are going to answer some questions, because that's what we often do in experiments. So we want to ID what reaction is occurring, what the limiting reaction is, why does the lava lamp effect even occur, and what stops it from occurring. So as I said, I've done this before and I watched the video, so I have an idea what's going to happen, but we're still going to do the experiment because that's what we do when we want to figure something out. So I have the elements, excuse me. I have the elements next to me. I'm going to put a towel down just with oil. We don't need that everywhere. Okay, so we're going to take an old Pepsi bottle that I have here washed out, ready to go. I'm going to take my water just filled up from the tap, and I'm going to dump it in here, doing my best not to spill. All right, we spilled a little bit, but that's why we have the towel. So as you can see with my beautifully drawn diagram, we filled up water in the bottom about a third. So next we are going to take our vegetable oil. We are going to dump it in. I'm going to try to do a little better this time, getting it in there. There we go. As you can see, the water and the oil are interacting right now as I pour it in. All right, we won't fill it all the way, just so we have a little spare room for adding the Alka-Seltzer tablets. Okay, so as you can see, they are distinctly separated. So that is because, as this says, water is more dense than oil. So the molecules in our water are more closely packed together than what is in oil, which makes them more dense. Okay, so we have that in there. We have them separated. Then we're going to add some food coloring. I picked the color green to match. We'll just pour some drops in there. You can see them. They're at the oil level right now. We used it all out. Perfect. Okay. Next, we are going to do the fun thing, which is adding the Alka-Seltzer tablets. These are off-brand of them because we're on a budget, but same idea. So we are going to take the Alka-Seltzer tablets, and as you can see, nothing is really happening. The food coloring dropped below into the water. The oil's up there. Cool stuff. Okay, now I'm going to take this, pop it in there, find my lid, just in case, and we start to see things are occurring. So if you look on the bottom, you have fizzles happening that are going up to the top. Bubbles are creating. I'm going to add one more just so we can see it more evidently, but it's starting to go. Okay. All right, so we added the Alka-Seltzer tablet, and that, in my opinion, is what the limiting reactant is in this experiment, because before we added it, nothing really happened. We knew that our water was more dense, so it was on the bottom, oil on top, all that good stuff, but no bubbles were being created, nothing was really happening there. So when the Alka-Seltzer went down into the water, it made carbon dioxide because it reacted with the water. So then bubbles attach themselves with the food coloring, move up into the oil, bubbles move, fun stuff like that, and then the color sinks back down after the bubbles pop. So, as I said, without the Alka-Seltzer, this would not happen. So that is why I believe it is the limiting reactant. And this occurs, moving down to this question, this occurs because it's making the water remaining gas become more dense than the oil. So the balls move up and the oil joins the water and they move back and forth, creating different gases. So it's cool to see how the Alka-Seltzer created that carbon dioxide that is moving the bubbles up and down. And when it stops, when the Alka-Seltzer runs out. So when I was looking up things for this, it said, or on the video, I'm sorry, it said Alka-Seltzer usually lasts like 5 to 10 minutes. So we could double that since I put in 2. They were a little smaller, so it'll probably be around 5 to 10 minutes anyway. So when the Alka-Seltzer is done reacting with the water, when it's all gone, then the lava lamp effect will stop occurring. So I think that covers why the oil with water and Alka-Seltzer creates a lava lamp type of reactant. And yeah, pretty cool. Thanks for watching.